Let's look at the line following program in its entirety. So this is my attempt at line following for the alphabet. A little disclaimer, if yours doesn't work, line following is dependent upon a lot of factors, so experimentation is needed. I advise that you look at the previous videos in the line sense module, because they do discuss a lot of the theory. And this is by no means the best way of doing it. If you can find a better way of doing it, by all means share it with me and with the community. We are all here to learn. So we've got our configuration, the standard stuff that we know and love. And here we get to some new stuff. Define, use HPWM1 true and use HPWM2 true. The microcontroller has got two pulse width modulation modules that are independent of the core. What that means is it can create a constant PWM on a pin without the core needing to give attention to it the whole time. So you write to the PWM module what it needs to do, set and forget, and your program goes on with whatever is necessary. And when the situation changes for the hardware PWM, then your program has to then give attention to the PWM module. So it's independent of the core. It can run on its own. But we have to tell Great Cow Basic that we are going to use it. Otherwise, Great Cow Basic won't use it. So it won't send the commands to the PWM module. And that's what this define does. It tells Great Cow Basic we are going to use those two modules and initialize them and set them up for us. We are very familiar with directions sitting there, so I'm not going to discuss that. Here I defined reverse and reverse 2, standard stuff, nothing really new, and our variable line sense as a byte. Now we're getting to starting the program. So here we've got our initialization. I set my reverses off so that my robot can run forward. And I set line sense as 0. This is just like I said previously, to make sure that my variables are in a known state. And then we have our friend wait while port C equals to 1. Port C 4 is always the button. And if it is 1, it's not pressed. If it's a 0, it's pressed. There's nothing we can change about that. But I put that okie there as usual, because if you press reset, then your machine starts running off the table and all in all. So we know about that one as well. Right. Now we get to another thing that is new, and it is do. And do, and if we go down here, we will find loop. So do loop is another way for us to do a loop, as the name implies. In the previous programs I used goto, but the advantage of do loop is that you can actually do it conditional. So you can have a while, so while something is true, do the loop, or if it is untrue until it becomes true, do the loop. And the same, well, here at the bottom, the difference between putting the condition at the top or at the bottom is if you put the condition at the top, It checks the condition and then executes the code. If you put a condition at the bottom, it executes the code and then checks the condition. But in our case, we are actually not putting any conditions in there. So we are running, as they say, an infinite loop. Now we get the next part of the program that we get to. I've discussed this in a previous video. Line sense 0 gets set as a 1 if my analog reading detects a line. Same with the second bit and the third bit. And here we get to the case, which was also discussed in a previous video. If line sense is a certain value, it does these actions. Now we get to the subroutines, and here it gets interesting because this is also new things. Now we are all familiar with using subroutines, I hope. So here I said the subroutine is called forward, and that is what to do when it has to go forward. If we scroll back up here, if line sense is 2, then go forward. Or if line sense is 0, then go forward. So that means if I've got a line in the middle of my line sensor, I go forward, or if there is no line, the robot goes forward. So let's look at that subroutine. Well, for forward, I do not want the thing to reverse, so I turn off all the reverse. And now we get some new commands. At the top of the program, we initialized the hardware PWM module. Now we are sending a command to that hardware PWM module. We are telling the compiler we want to use hardware PWM. We would like to use module 1. 100 is the frequency at which it runs, and it is measured in kilohertz. I've not found any rule of thumb that says how fast you must run this. The basic consensus out there is that you must avoid audible frequencies because that would make your robot go shwee and things like that, and that is annoying. But another thing that I also read was that you must look at the switching speed of your hardware. If your hardware can't switch very fast, then you won't get high frequencies to work. It will miss most of the pulses. I also read that if you make it too slow, your motor and your switching gear can overheat. So this is a very difficult number to find somewhere, and I found it through experimentation. I basically put my finger on the H-bridge chip, ran a couple of frequencies and held the motor and felt with my finger whether the chip gets very hot or not. And I used a frequency that gave me the best heat results. But another thing also that they say is the frequency does influence the amount of torque that your motor can produce. So if your frequency is too low or too fast, it influences the torque as well. If you need to know about torque, go Google it. Right, and then this one is the duty cycle. That means how long it is turned on or turned off. Now this is a bit of a misleading number, because a duty cycle of 0 is off fully, and a duty cycle of 255 is on fully. And what do we recognize about 255? It's the maximum number that can be stored in an 8-bit byte. Look at that. This last one is the timer that needs to be used. We haven't discussed timers, but the Bots microcontroller, I think, has got 4 timers in it to do different things with. We will definitely be using some of those timers in future videos when we do odometry. So for now, don't worry about timers. Right, so in essence what is happening here is, if I want my robot to go forward, I make sure that the reverses are off and I give speed to my 2 motors. Right? If I want it to turn left, I turn left reverse on and right reverse off. And that means it will spin in place. The one motor will go forward, the one motor will go backward, and it will have the robot spin in place to the left. And I decided that I'm going to give, it says here, full power. So I give 255, 255. That means all the way on. And I actually do the same with turning right. The only difference is that I swap which motor is on and which motor is off, and I give it also full power. So it's not a very smooth line following, it's a bit jerky, but it does get the job done. So if we look at this program again quick, we will see it consists of 3 or 4 basic building blocks. We have our setup, our initialization, which is here. Then we read what's happening on our line sensor, and then we execute according to that what the robot needs to do. Now again, and it gets repeated more than one time. So again, you can actually take this piece of code and replace it with a command that says, or a subroutine that says, say, sense line. Okay, we can't use that, we need to put in an underscore, sense line. And then here at the bottom, right, and that makes our program very straightforward. Okay, sense the line and do something about it. So we can even do this. I spelled it wrong. So now the program is very straightforward to read. It says, sense the line and do something. There you go. So the program can be broken up into segments, and each segment does something on its own. And then you combine those segments to create a full-fledged program. And that is the essence of programming. Taking a big problem, breaking it up into small problems, and then applying the solutions to the small problems.